game. So basically this is one of the toughest problem when I started. As you can see, there are many mistakes I did. uh, Sorry, yeah, so this is one of the toughest problem for me when I begin. So now I found two approaches. One is from the beginning, you find which is the furthest reachable position, and uh, and you calculate what is the maximum position you can reach from 0. For example, we will take 32104. So from 0 position you can reach to third position of this array. Okay, so the furthest reach position would be 3. So here it would be first one, I index is 1, num of I is 2, so the furthest reached would be 3. In same here, the furthest reach would be 3. So when the I is greater than the furthest reach position, then it would return false. So that is the concept which we're going to do first. So what we need to do is find the length of the array, and have the furthest reach position as 0. So we're starting from 0, and your max reach position from current. So from current, your max reach position would be I plus nums of I, right? So that is what we're going to do. Is nothing but I plus nums of I. Okay, so now we will check if if this position is greater than the furthest reach position. So if yes, then we will make this as a furthest reach position. So always we will take the greater in the left hand side. So now you make furthest reach position as current max reach position. Okay, so and if furthest reach position is greater than the length of the array or equal to the length of the array, then we can say that you're able to reach the position. And -1, then you return 2. Okay, then yes, you return false. So we test it with this. So nums is not defined. Okay, num yeah, this works, but this will not work. Reason is yeah, this will not work because we need to give a condition here that if here what happens is maximum it can reach is 3. So as you can see, so maximum from here it can reach till 3 only, so it cannot go to this position at all. So what we need to check is for every ith index, is it greater, is it lesser than the furthest reach position? That needs to be checked, and then only you can say that is it right. If I is greater, then it means you cannot reach that position. So now if you test this use case, okay, some spelling mistake. Yeah, now it would just return you this. So the only thing we need to consider here is for every index, when you check, verify if it is, you know, less than the current reach position, because this position is not reachable, right? So this position is not reachable, right? Maximum you can reach is only till 3 0 1 2 3, and when it comes here, obviously it's greater than the furthest reach position, and hence it will return false, right? Another test case which would be a good indicator is 0 comma 2 comma 2. So here it would fail. So yeah, so I'm just submitting it would, yeah, get accepted. Yeah, okay. So this is one solution. So another solution is, so from the behind, so from the last we'll try to go, like from here we'll get the last good position. So last good position is from from the last, so that would be the n minus 1. So from here, if you iterate, and if you're able to go to the uh, uh, next position, for example, if you're able to go to 0, then it is uh, like you can return true, else you can return. So I'm just gonna, so this is, we are iterating from behind. That will be n minus 1. Okay, so we'll iterate from here and verify if it's possible to go to 0, right? So if I plus num of I is greater than or equal to last good position, that is, from here can I go to the last good position. So that means from here can I go to n minus 1. So that is the logic which we are going to go now. If I plus num1, then your last good position is I. Okay, if your last good position is less than or equal to 0, then you can return true, else you return false. So previously we went from 0 to n with furthest. Here you just calculating from the last, can I go to the next position. So from this n minus 1, I'll be always, it's always a safe place, so by default it's good. That's why we put n minus 1 sorry, and then we iterate over here to this position, and if this position is from here, can I reach here? So then the good position would be this is 3. Then you iterate from here, can I go to here, the last good position? If yes, your last good position would be 1, 2. Similarly you go, and if your last good position is 0 or less than 0, you return true. So we'll test this. Yes, if this worked. So we'll also test this use case. Yeah, this should work, I guess, else we'll debug. just let me check. Yeah, it's working. So we can do this in two ways. One from the start to end. That would be a furthest reach position. So here it's like last good position. So it's pretty, you know, intuitive problem, and it's a good problem to solve. I spent more time. Like I would have spent around 5 to 6 hours from the start to solve this. I used lots of techniques, memorization and TP, but I do get lots of TLEs. You can see. So these two techniques are pretty good. So I'll see you sometime. Thanks.